Hello, and welcome to this Let's Chat Wi-Fi Lab. My name is Karen Emmons, and I'm a VASO board member, one of the technology event group leaders, and a national event supervisor. I'm accompanied today by Ian Emmons. Give me a second to spotlight the two of us here. All right. Ian, who you may remember from such great video classics as Let's Chat Bridge and Let's Chat It's About Time, works for Raytheon BBN. He too is a national event supervisor and the other technology event group leader. And he was an event supervisor for Wi-Fi Lab 3 times for VASO last year. He also is on the national committee that wrote these rules and has authored parts of the documents that appear on the national event page for this event. In our time this evening, we cannot possibly cover every rule or situation in the rules or VASO clarifications. Nothing we say here today supersedes a rule or clarification. You'll still need to read the rules. Read the rules often, because every time you do, you'll see something else and then reread them again. And don't forget about the VASO clarifications on the website, which are as binding as rules. As we get going, I encourage you to put your questions in the chat. I'll keep an eye on them and insert them where appropriate and make sure that they get asked. So again, Ian, thank you for joining us.
You bet.
So actually, Ian has so many documents open to share with everybody. He's asked me to start this off a little bit with our own screen share, just to show you that on the VASO website, this is the VASO webpage for Wi-Fi Lab. To get there, you go to our website, you go under middle and high school, go to events, go to Wi-Fi Lab. But I want you to see that there are a lot of resources already on this page. This is the page where the Let's Chat will be inserted, so you can find it afterwards. These are the slides that Ian will be showing tonight. You're certainly welcome to open them on your own computer if you want. But these two documents, the construction tips, Ian wrote these based on where people went wrong last year, and the Wi-Fi Lab transmitter construction and setup guide. That's if you want to build your own testing transmitter, a lot of very detailed instructions in there. Now we're going to be smushing all of that and covering all of that tonight in a more compressed fashion, but I wanted you to know about where you could go back again to find some more very detailed information for that. All right, Ian, so let's just start with the basic question. What is the task of Wi-Fi Lab?
Sure. So in Wi-Fi Lab, this is a typical physics event in Science Olympiad, which means that it comes in 2 big pieces. The first piece is to complete a written exam on, in this case, electromagnetic waves. And then the second piece is a construction task where you build an antenna that transmits a radio signal as far as possible. And for convenience, the signal that we use here is a standard Wi-Fi signal, and that's how the event gets its name. But this actually introduces a bit of confusion because the event is actually about antennas. It's not about Wi-Fi or computer networking.
Great, and that actually can often provide confusion for venues or maybe your own school as you're practicing. We have a statement and some resources for you to use if you're having anybody question practicing this event. We'll show that at the end. Now, normally at this point, we would go straight into talking about the antennas, but we're gonna mix it up a little bit tonight because there are so many questions. You know, you can build the antenna, but you have no way of testing it if you don't know about the testing equipment and some of the confusing pieces of that. So that's actually where we're going to start, right? I know Ian is going to start talking about connectors.
Right. It will just help the rest of our discussion to be much more understandable if we say a few words about these special SMA connectors that we use in this event. So I've made a slide here that shows the 4 different SMA connectors that you will encounter, and I've tried to demystify these. So they're all a kind of coaxial cable connector, and they differ in two different ways, whether they have a pin at the very center or a hole at the very center, and whether the threads are internal threads or external threads. So the left-hand column here, those two connectors have a center pin, which you can see right in the middle. And then the right-hand column, those two connectors have a center hole into which the pin fits. The first row has the internal threads. So it has a collar with threads on the inside that twists around. And then the second row has external threads, um, and that the collars of the first row would screw onto. So, and then in each cell, I've got the label that they call it by. So when you have a center pin and an internal thread, that's an SMA male. When you have a center hole and an internal thread, that's an RP SMA male. The RP stands for reverse polarity. When you have an external thread and a center pin, it's an RP SMA female. And when you have a center hole and an external thread, that's an SMA female. So, it may help you to keep these pictures handy to refer to as you're working through all the details of your test setup and your antenna. I know I can never keep them straight. I always have to go back to pictures like these in order to figure it out myself.
This is an amazing resource, Ian. And yes, I would print this out and have it, or just always have it open. It is the first slide in the slides from the Let's Chat on the website. So that's where you find this really useful picture. So let's continue on there. Now that we know that there's 4 kinds of connectors and you will be referencing all 4 of them, what does the device test setup look like?
Yeah, so we're going to actually start with the whole test setup, just because it gives you an overview of what it's like to run the event and how all the pieces fit together. And so I made this little sort of cartoon representation to understand that. So over on the left here, we use a standard Wi-Fi router as a signal generator. It's not connected to the internet. It's we're not even connecting a computer to it. It's just generating a radio signal that we will use to test the antenna. And then there's a cable that goes from that router to carry the signal to the antenna. There's what the rules call a backplane and a tripod that are used as kind of a support for the antenna. And then there's the competitor's antenna itself. I've shown a Yagi style antenna, but lots of different kinds of antennas work well in this event. That's just one kind. And the competitor's antenna will fasten to an SMA female that's connector that's in the middle of this backplane here.
We're going to blow this up, so you'll see this a little bit more detail with the name of the connector in a minute.
Right, absolutely. So and then so the signal comes from the Wi-Fi router and goes through the cable, through the SMA connector into the competitor's antenna, and then their antenna radiates a signal through the air. That's the waves I've shown over here, and then there will be a laptop. Or an iPhone works as well, but a laptop is what I typically use, that serves as the measurement device for measuring the strength of the signal that is received. And then the distance from the backplane to the laptop is what we call the connection distance, and that's very important for scoring. We'll discuss a little more about that later, but when we talk about connection distance, it's the distance from the backplane to the laptop that we're measuring with.
Okay. Great. Now I think you have a picture of
Right.
our own setup too, just to
Right.
show what it's going to look like.
So this is a pair of pictures of the setup that we use at Vaso Regionals. On the left is a sort of front view. This fiberboard is the back plane with the SMA female connector in the middle where a competitor would attach their antenna. And then on the right, I've just shown it from the back where you can see the cable coming out the back of that connector connects into the Wi-Fi router that's sitting on the floor there. And we'll talk more details about all of these things as we go through.
One of the things that I'm noting and that I think is important to realize in our setup, the back plane is attached to a tripod, and the tripod can be moved. So the back plane has the ability to be moved to being flat, right? All you have to, there's a little handle there and you can move it around on an angle or twist it and turn it and even have it be flat. So that's one of the values of having it on a tripod in tournament.
Right. Some in these pictures and in the diagrams I've shown the back plane as being a vertical thing, but some competitors actually want it horizontal, and that's just fine.
Okay, great. Thank you. Looking to see if we have any questions. No. All right. So how do we make, if I'm a competitor, and how do I make something where I can test my antenna?
This is important. So you don't need to bring the testing setup. You don't need to bring what's shown in the picture here, the router or the tripod or the backplane. You don't need to bring that to the competition because the event supervisor will supply all of that. All you really need to bring is the antenna itself. But you will need some kind of a test setup so that you can test your antenna designs at home and calibrate and so on. So I'm going to show a couple of ways to do that. So this first approach is an easier, more minimal test setup that is actually enough for many competitors and makes it a lot easier to get going. So you will need the router. I haven't shown the router here. We'll talk more about the router in a few minutes, but you'll need one of those. You'll need a cable that goes from the router to your antenna. And at one end, that cable will need to have a connector that connects to your router. So you'll have to look at your router. Not all routers are the same, but it's oftentimes you'll need an RPSMA male at that end of the cable in order to connect to the router. And then at the other end, you'll want an SMA female connector, and that will connect directly to your antenna. No backplane, no tripod. You don't need to make all of that stuff most of the time. And then you'll use something, some sort of, whatever you've got laying around the house. I've just shown it as this gray rectangle, but maybe it's a pile of books or something to hold your antenna at the right orientation and level. And so in this setup, you're just using a cable to go direct from a router to the SMA male connector that must be part of your antenna. And there really is no more to the test setup than that. Now,
I'm gonna reiterate something here that I think is important, and I know you're going to discuss the antenna design later, but I think it's worth saying here because it's so important. The SMA male connector is provided, that's you're bringing that to, that is part of your antenna. Without that, you won't be able to connect to the SMA female connector. So you've got, as you're designing your antenna, it's got to have an SMA male connector on it. We don't have those.
That's a key part of the construction parameters. And we're going to go over that in a few minutes. Okay, so this is sort of the easier test setup that leaves out some of the finer points that an ES would need. But if you wish, you can certainly build the full complete test setup. It's a little bit more effort, but it's not particularly hard. But let me just show you what's different when you do this. So the main difference is you're still going to have a router, and you're still going to have a cable. The cable is going to have one end that matches up to your Wi-Fi router as before. And then the other end, instead of having an SMA female, you're going to have an SMA male. And the reason is because in your back plane, you put an adapter that is, this is the name of it here. It's an SMA female to SMA female bulkhead mount adapter. And I've got a picture of that in the lower left here. But the idea is that that's what fits into the hole in the back plane. And it screws in there with the nut that comes with it. And then the SMA male connector on the cable connects to that, and the SMA male connector that's part of your antenna connects to the other end of that. So that's sort of the little difference there, is that that you actually end up wanting a slightly different cable if you're going to build the whole 9 yards of the complete test setup. So, and then, to build the backplane, I'm not giving you detailed instructions here, because if you look at the transmitter construction and setup guide that's on the website that Karen showed at the beginning, that has very detailed instructions on how to build that backplane. So we don't need to go through that here. So one other note about this is kind of important. In your antenna, when you come to the tournament to test, your antenna needs to be supported by two things: the SMA connector that is in the backplane and the backplane itself. And most people's antennas are quite light, relatively small. They've got the SMA male connector on there in a kind of a rigid connection, and they just screw onto the SMA female in the backplane, and they never even touch the backplane. They're just held up by that SMA female to SMA male joint. And if your antenna is like that, then this test setup, the easier test setup, will work very well. But I have seen some antenna designs that are a little bit bigger, a little bit bulkier, and they, in addition to attaching to the SMA connector, they also kind of rest on the backplane. And so if your design is like that, you might actually feel like you need to build the backplane in order to be sure that it works properly. But most of the time that's not necessary.
Great, thank you, Ian. I'm going to take a second, check the chat, see if we have any questions, because that's a lot of information, but these pictures really help that. And I can see then, so you still end up with the SMA female on that the connector that the antenna has to connect to. It's just the presence of the backplane means you have to have that adapter, and that's what makes that funny. Okay.
Mm-hmm.
I don't see any questions, so let's move on. So that was how to create your own testing setup. Let's go back into now the event and start thinking about making the antenna and how we're going to score that. So how is the event scored, Wi-Fi Lab?
So as is typical with physics events, the scoring is a little bit complex. So a high score wins, and your total final score is the sum of several components. The first component is your exam score, and that counts for 45%. The second component is your antenna score, which counts for 40%. We'll talk about how that's computed as we go forward here. There is a chart score for charts and graphs that you make that is 10%. And then there is a bonus, a max bonus that can come into play that is 5%. The max bonus is is actually fairly rare to be awarded, but it can be. So the exam score and the antenna score, it's interesting how they are incorporated. They're I'll explain this with the exam score. So the exam itself might have, it might have 100 points, it might have 143 points, it might have 72 points. We don't know how many points it'll have. But then we take that raw exam score and we scale it so that the best exam score comes out to 45 points. And then we use the same scaling factor on everybody's exam score. So, so what this means is that even if the exam is very, very hard and nobody scores very well on it, the exam still counts for 45% of the total score. And the antenna score is similarly scaled to be 40%. So what is the antenna score? It's the best successful connection distance. So you remember we talked about the connection distance being the distance from the backplane to the laptop that measures the signal strength. And it's the best connection distance, the farthest connection distance. So that is sort of the goal of building your antennas. You're trying to transmit that radio signal as far as possible.
So it's not about signal strength. It's not, I mean, I know that that's going to play a factor and you're going to even talk more about that, but the strength of the signal is not the score.
Correct. It's the distance. And then to just round out with some of the details, the max bonus comes into play if multiple teams achieve connection at the maximum distance, at the biggest distance that the venue will support, which is typically the very end of the hallway. And in that case, the team with the highest signal strength at that max distance will receive a 5-point bonus. There's another little detail. If you read carefully in the rules, you'll see that there is a thing called a submission bonus for bringing your antenna in a box. We actually have a clarification on our website that eliminates the submission bonus because we are not, this is not an impound event. And so that whole bring it in a box thing doesn't really have much meaning for us.
But that again is only VASO. So if you're going to tournaments other places.
True. And then there are some tiebreakers. The first tiebreaker is the best antenna score. The second is the best signal strength at the maximum distance. The third is the number of successful connections. And the fourth is specific exam questions.
All right. Is there, we've had a question. I'm going to hold that, Bradley. We're going to talk about that as we talk about the antenna. All right. Let's move on to what does this look like on tournament day then?
Sure. Okay, so the students are going to bring their antenna, and as I just mentioned, there is no impound in this event this year. So you just bring it at your competition time. You don't need to bring it early in the morning. And then the event supervisor supplies the testing setup. So the Wi-Fi router, the tripod, the backplane, the cable, and the laptop. Students don't need to bring all of that stuff. Students will then attach their antenna to the female SMA connector on the backplane. And after they do that, they make 3 connection attempts. And each connection attempt looks like this. The students first specify a distance, and the event supervisor moves the measuring device, the laptop, that far away from the antenna. The backplane and the tripod stay in one spot always, and it's the laptop that moves. So students specify a distance, the ES moves the laptop to that distance away. And then the event supervisor will measure the signal strength at that distance. If the signal strength meets or exceeds the threshold value, then the connection is successful, and the score for that attempt is the distance, not the signal strength, it's the distance. And then the overall antenna score is the maximum distance that that team achieved a successful connection.
So you talk about, so you mentioned a threshold. What is the threshold?
Yeah, this is important. So before the competition starts, the event supervisor will measure a threshold signal strength, and they do it like this. They first create a monopole antenna from a paper clip. It's just, you just straighten out a paper clip, you cut it at a specific length of 3.1 centimeters, and then you insert that into the little hole in the middle of the SMA female connector in the backplane. And that's sort of the simplest, most basic antenna that you can create. And then you measure the signal strength of that at 3 meters. And that signal strength is the threshold value. And really what that is a kind of a measurement of how are the radio waves, how strong are the radio waves for the particular router in the particular environment and with that particular laptop measurement device, so that all the other measurements are made relative to that threshold value.
So since it's a product of the environment, it's
Right.
not something that VASO can announce ahead of time. We can't announce the threshold for a tournament since it gets measured that morning.
That's right. That's right. So, just as an example, if you were to do this event in a very broad open space, like in the middle of the football field, you would get a somewhat lower value of the threshold value. But if you did it in a hallway that had lockers lockers are made of metal, so they reflect radio waves, then you get a much higher threshold value.
But presumably everybody's antennas, right. Because we're measuring at the thread. If your antenna works well, it'll still, and it's exceeding the threshold as you all test it, in your home settings, then it should be exceeding hopefully the threshold. Because if they don't exceed the threshold on that connection attempt, that one of the 3 gets a score of 0 then, right? Correct. Of no distance. Yeah. But then they get to change the distance on the next attempt, right? So they can just say, okay, well then let's shorten the distance or something like that.
Exactly.
Okay.
Exactly.
How do we measure signal strength? Right. So let's make sure that everybody understands how we do it so that they can do it in a similar fashion.
Okay, so I've got a slide to share for that as well.
Mm-hmm. As you're getting ready to share that slide, Ian, we have a question. Is there a general range we can expect the threshold value to be in?
Oh, yes. I will actually talk about that right now. So timely question. Okay, so what we do to measure signal strength is we use a laptop or an iPhone that is running special software. Laptops and cell phones obviously have the ability to receive a Wi-Fi signal, and then using special software, they can actually measure the strength of that signal. On a Windows laptop, the program is called Wi-Fi Info View, and you can see the URL there for it. That URL is also given in some of the other information documents on the website. And download that, install it, and it will be really quite straightforward to use. On a Macintosh laptop, there's a thing called the Wi-Fi scanner tool that's built right into the operating system, so you don't even have to install anything. And I've got some specific instructions on how to start it. It's a little bit weird. It's not just a normal application. It's buried in a utility there. If you have an iPhone, you can also download an app called Airport Utility, and there's some instructions there on how to get that started. No matter which one of these three options you use, the display will show a table that has a row for each Wi-Fi network, and several columns with different quantities. The column that you want is called RSSI. It's in units of dBm, which we typically call decibels. And decibels are kind of a funny unit. So just to answer your question there, the typical values are negative. They're usually in the range roughly of -40 to -90. I've seen them a little bit outside that range, but not a lot. But the key thing to remember here is that these are negative numbers. So that means that -40 is a stronger signal than -90, because -40 is bigger than -90. It sort of messes with your intuition a little bit there. And the other thing to know about decibels is that this is a logarithmic scale, kind of like the Richter scale. So -40 is 10 times stronger than -50. -50 is 10 times stronger than -60, and so on. And every 10 decibels is a whole factor of 10 in signal strength. So it behaves a little bit oddly that way. Yeah. So hopefully that answers your question. I can't give you an absolute guaranteed in this range, but -40 to -90 is approximately where you'll see signals most of the time.
Well, and again, you can do this test yourself as well too, because you have access to a paper clip. You just unbend it, clip it off at 3.1 centimeters, and stick it in the SMA female character to test the threshold where you are, right?
Right.
So it's occurring to me, as we're talking about measuring signal strength, we need to talk about getting the signal out of the router. And I think that we haven't addressed that, which is actually, there's some tricks, and you have, I think, some pictures for that as well too. So
Yeah.
can we go back to that? I think that
I probably should have talked about this as part of creating your test setup. But now is as good a time as any. So let me share a slide. So we saw this before. This is the picture of the complete test setup, and I'd kind of left the router out of it here. And so now we're going to talk about how do you prepare your router for use. So this is one of the routers that I use. It's a very plain vanilla basic router, and most routers will be very similar to this. And so I've labeled on this picture a number of the things on the back. These ports in the middle here are the Ethernet ports, and there's some USB ports. Those you can completely ignore for this event. They just don't play a role. There is often, not always, but often there is a coax connector on here that you will also ignore. I'll say a few more words about that in a minute. And then the sort of, there's these antennas here that stick up that actually transmit the signal. And the obvious connection, the obvious question here is, hey, aren't there supposed to be some SMA connectors? And a lot of people see that coax connector and they think, oh, that's the SMA connector, and it's not. It's a much larger connector. The SMA connectors that you actually are concerned with are hidden by the antennas because the antennas are attached to them. So those just unscrew, and I've shown this is the same router with the antennas unscrewed, and you can see the SMA. These are RP SMA female connectors here and then over on the other end. And you can see the RP SMA female and the coax are kind of similar looking, but the coax is much bigger. And the coax is not transmitting the radio signal that you need. So I've had teams get confused by this and connect their antenna to that coax, and they were just getting completely bogus data that way. So the key thing here is that whatever router you use, it must have external antennas. There are some routers where the antennas, it appears not to have any antennas. It does, they're just inside its box. And you can't use those because you have to be able to access these antenna ports to connect to your antenna, so that your antenna can transmit the signal from this router.
Well, it's even, and ours even has the nice little antenna signal beside it too, so.
It does, yes. So, okay, so in order to prepare your router for the event, you noticed a couple of pictures ago that there were actually 2 of those SMA connectors in the back because there's 2 antennas. We're only going to use one of them, and you should cover up the other one with some aluminum foil. And I just crumple some aluminum foil around it and then put tape over it to hold it in place. And that way you're not getting some extra signal leaking into the environment from that second port that is kind of messing up your data. So once you do that and connect your cable to your antenna, your router will look like this. It will have no antennas on the back. One of the ports will be covered up, and then the other port will have that cable leading off of it.
Great, and then that's it. Are there, I know that routers run with software, that kind of stuff. Do we have to make software adjustments or anything to the router to work with it?
Most of the time, no, not at all.
Okay. So you can buy an old router on eBay or whatever, and as long as it's got the external antennas, it should work.
Right. Yep.
Okay, great. That was a good route there, as we talked about making the signals, having the signals come out. All right, we have discussed an awful lot of setup, of testing, what you're going to see. What makes for a good antenna in this event?
Right. So there are many different kinds of antennas, and no one kind of antenna is best for this event. I've seen people be very successful with Yagi antennas, biquad antennas, helical antennas, and some others. Go do a little bit of reading about antennas and think about how you would make it, and pick one and give it a try. And I will say it's really easy to get started in this event. Just build something simple and try it. I know I just rattled off a whole bunch of terms about different kinds of antennas. They're mostly most of them are really relatively simple, and even if you don't build it quite exactly right, if you just build something that looks like the pictures you see, you'll get some results, and then you can iterate on that and build a second version and make it a little bit better. But it's very easy to get started, and the materials are very inexpensive. So experimenting with a few different antennas is entirely reasonable. I will also say that many competitors make good use of digital fabrication, and more specifically 3D printing. Obviously, some parts of your antenna have to be metal in order to conduct the electricity and the radio signal. And most of us do not have access to a 3D printer that creates metal objects. But what I've seen is a lot of competitors use 3D printing to create the sort of plastic supports for the metal pieces. And that can be quite useful. But I will say it's certainly not required. Very successful antennas can easily be made without 3D printing. So don't think that you have to be doing 3D printing. It's just something that some people do find useful.
Thank you, Ian. So I'd like to go back, and if you could go back to the picture, we're going to go back to the previous topic for just a second about setting your router and getting the signal out of it. Could you go back to the picture where you cover the additional antenna? Somebody would like to know a little bit about what kind of tape you're using, and is it the tape that's blocking the Wi-Fi signal?
That's a good question. And the answer is no, it is not the tape. Any kind of tape that sticks will do. It's the aluminum foil. Okay, so just to take a look at the SMA connector uncovered, you can see it's got this pin in the middle, and it's got the threads on the outside, and those are the two conductors of the cable. That's why it's called coaxials, because the one is around the other. They share an axis. So so when you cover it with foil, with crumpled up aluminum foil, as in the middle picture, what happens is it prevents the signal from the center pin from going anywhere, because the foil is electrically connected to the outside of the outside threads just by pressure, and then the tape just holds it on.
So yeah, so it doesn't matter what kind of tape, the tape is just securing the foil.
Right.
Great, thank you.
Does the job.
All right, thank you. So let's move on now to the construction basics. What are the required parameters for the antenna?
Right, so first of all, the antenna must fit within a 15-centimeter cube. It's not a large antenna, and it may actually use the diagonal of the cube if you want to be a little bit larger. I've made a 15-centimeter box that all you have to do is just show me that your antenna will fit inside of it, so we can measure it very quickly that way. But that's the maximum dimensions. It can be constructed of any materials except for magnets or commercial antenna parts. It must be passive, which means no batteries, no AC power, no other energy sources in the antenna itself. And you must design it and use it in a way that does not damage or alter the backplane or the backplane's SMA connector. And for that purpose, the rules recommend that your antenna be no more than 300 grams. That's not an absolute limit. If you have a little bit heavier antenna, just make sure that you've thought about what's holding it up, that you're using that back plane to bear some of that weight so that you're not putting too much stress on the SMA connector in the back plane.
Thank you. Does that answer the question? I guess, yes, we had a question about a defined weight limit. So thank you. I think you've addressed that. Now, again, we had the trickiest construction parameter is the connector. So do you want to just say it one more time? Because we saw so many antennas that couldn't connect. It's so disappointing.
Right. Your antenna must include an SMA male connector. So you're gonna need to buy an SMA male connector and then solder or otherwise electrically connect the components of your antenna to that connector, and then that will screw onto the female connector in the back.
And we're talking about the SMA male, not the reverse polarity SMA male.
Right.
The SMA male.
Yes, exactly so. So, and then the related construction requirement is that your antenna must be supported solely by the backplane and the SMA connector in the backplane. Nothing else can hold it up. Although, as you mentioned earlier, Karen, the backplane does rotate to any orientation, and competitors are allowed to take advantage of that.
So they can make it be flat and just rest it that way, so it's not putting pressure or pulling on the SMA connector.
Correct. Yes.
When we say it has to be supported solely by the backplane, we're saying things like it can't have an extension down to the floor. Well, it would be too big probably if it's down to the floor, but could it, if this is the backplane and my antenna's here, can I have created a little plastic part that kind of leans against the backplane, something like that? That's supported by the backplane too, right?
Yeah, and I've seen competitors do that, where the SMA male connector is up kind of at the top of their antenna, and then it had 2 feet that reached down and rested against the backplane, so it was sort of like a little tripod there supporting the antenna. So that's a kind of a clever way to use the backplane if your antenna is a bit heavier.
Right, thank you. So where do people, so other than the connector, having the wrong connector, which we've, I think, beaten into people, so what are the other ways that people go wrong with this?
Right, so we talked about make sure you have the SMA male connector as part of your antenna. We've talked about connecting up the router and how to do that. In past years, we saw lots of people that had not connected their router correctly, and so they thought they were measuring a signal from their antenna, but it wasn't. They were measuring a signal just off of the bare SMA ports on the router, and so they were getting really just garbage data. Beyond those 2 things that we've really already talked about, there's a few different things. So one is that many routers actually emit 2 radio signals at the same time, and one of them is a 5 gigahertz signal that is associated with the Wi-Fi standard that's called 802.11 AC or AX. And then the other is a 2.4 gigahertz signal that is associated with the 802.11 B, G, or N standards. And you want the 2.4 gigahertz signal, not the 5 gigahertz. But this is actually relatively easy to figure out, because almost all the time, a router that emits both signals, what you'll see in the signal strength software is you'll actually see it listed as two separate Wi-Fi networks. One that's called whatever name it's called, and then the other one is that same name with a 5 at the end of it. The 5 standing for the 5 gigahertz. And
So you don't use the 5.
And so just don't read the 5 one. Read the RSSI value of the other one, and then you're fine. Okay. So that's an easy thing to deal with.
Can I ask this question though? So let's say you're trying to get a router that's just for this purpose, right? You go onto eBay or whatever, you've got one, it's got external antennas. Do they make, if a router with the external antennas, do they make them or that they don't emit that lesser signal, the 2.4 gigahertz signal? Do you have to check on that as you purchase or get a router to use for this event?
I have never seen a router that only emits the 5 gigahertz.
Okay. Okay.
They almost always build in the 2.4 gigahertz as a backwards compatibility measure with older Wi-Fi devices.
Great. Okay. Just checking.
Okay, so other things that people do that cause them difficulties. This is just a straight up construction tip. Don't use hot glue. Hot glue is great for arts and crafts, but it is not a good structural glue. It does not hold a lot of force. It does not stick well to a lot of the materials that you will use in this event. And so you should use a different glue. Things that work well are things like epoxy or CA glue. If you're using wood, you can use carpenter's wood glue. Those will work much better. Another thing that people do is they don't make very good electrical connections. So if you have two pieces of metal and you want electricity to flow from one to the other, like from a wire to an antenna element, say, there's two good ways to do that. The best way is to use solder. And soldering is this process where you use a hot soldering iron to melt a kind of metal called solder that melts at a relatively low temperature, and that solder will flow onto both of the pieces of metal that you're trying to connect, and then when it solidifies, the electricity flows between very, very well because it's continuous metal from one to the other. And that makes the best electrical connections. Soldering is not hard if you've never done that before, but it does require a little bit of practice. So you might need to read a little bit about it, or a great way to do this is to ask your school's electronics teacher to show you how, and they can show you in a short time how to do that well. There's a couple of things to know about soldering. Metals like copper and brass are very easy to solder, very easy, but aluminum is very difficult to solder. So in that case, you want to connect it a different way. Oftentimes, like using screw terminals is a good way to do it. Where you're using the kind of the force of a screw to push two pieces of metal together, and that makes a good electrical connection. And then one other thing that people get wrong about solder joints is that solder joints are not mechanically strong. So don't expect them to hold a lot of weight. If you need a joint that holds a lot of weight, make a mechanical joint that holds the weight, and then solder to get the good electrical connection across that.
I'd like to put a plug in too. You and I went on a trip somewhere where we were constructing something, and I soldered for the first time. I was really nervous about doing it. I had never soldered before. It was really easy, and it was really fun too. It's not a hard thing to do, and there's little kits, right? You can buy little soldering kits at even like Home Depot or whatever, and practice it and try it and do it. But yeah, definitely don't glue your connections or your joints together and expect electrical.
Right. That's actually an important point. I'm glad you mentioned that. Glues, almost all glues are actually insulators. So if you glue two wires together, you probably are not getting a good connection between them. Okay, so what else do people do wrong? Um, another important thing is forgetting to measure your threshold value. Um, it I've seen teams that never measured their threshold value. They did everything else right, but they didn't measure their threshold value, and so what they were getting a signal strength. They could see the signal strength of their antenna, but what they didn't ever know is whether they were doing well or poorly, because they didn't know, am I exceeding the signal strength of the simplest possible antenna, or am I doing worse than the simplest possible antenna? They didn't know because they never measured their threshold. So make sure you do that in each environment where you test.
It sounds like something you should just do anytime you set up the test. You should just always, as a matter of course, the first thing you do is test your threshold, because it could vary even in the same setting by the day, right?
Um,
Hopefully not a
uh,
lot, but
Probably not. But if you change anything about your test setup, any of the components or the environment in which you're testing, that threshold value will almost certainly change. Um, so another thing uh, to keep in mind is a mistake that's common across all of Science Olympiad's building events, and that's building to the limit. If your rules have a maximum dimension, and remember we have the maximum of 15 centimeter cube, your antenna has to fit in a 15 centimeter cube. Don't build your antenna to be exactly 15 centimeters. Build it to be 14.9 or 14.8, so that you're sure to be within the limit, and small measurement errors don't leave you with a construction violation.
and that 15 centimeters includes that required male connector too.
Yes, it does. That's correct. Um, and then finally, make sure you leave enough time to practice. Build your antenna early enough to leave yourself a good bit of time to practice in a number of different environments and in a bunch of different ways, in order to calibrate your antenna, to know what your antenna can do, and to know how to troubleshoot it when something goes wrong.
Those are all great tips, Ian. I don't see any other questions, so I think maybe we should conclude today. We promised early on that if you were having any problems, anybody worrying about you running an event called Wi-Fi Lab in their setting, you had a document and some information to share to help smooth that out.
Right. So on the website that Karen showed at the beginning, there is this document, tips for competing in Wi-Fi Lab. And this is just the title page of that. But if you scroll all the way to the bottom, you'll actually see some familiar pictures in there. I used them again for the slides. But you scroll all the way to the bottom, the last section, it's called a statement to your IT department. We've had this a number of times. The people who run the networks and the computers in a school, which I'm calling it the IT department, the information technology department, although different places have a different name for that. Those people are very touchy about having other Wi-Fi routers in their environment. And the reason for this is that if a student brings a Wi-Fi router and connects it to their network, then the student can oftentimes inadvertently subvert all of the security that the IT department has worked very hard to create. And so the IT department is often very unhappy with people bringing a Wi-Fi router into the school. But what's different for us is that we're not actually using this Wi-Fi router as a network. We don't connect it to the internet. We don't connect it to a computer or any other device. All we're using it is a source of a radio signal that we can measure. And so it really cannot adversely impact their security. And what I've done here is I've typed up this statement that you can just print this page and take it to your IT department if they're giving you difficulties. And I believe that it adequately explains to them in their language what they need to know to say, oh yeah, these people are okay. So go ahead and use that if you're running into any sort of policy problems with using a Wi-Fi router in your school.
Great.
If you're not successful there, talk to your coach, and your coach can contact VASO, and we will endeavor to help you out further.
I think this is a great statement, and I thank you for that. We have had one additional question. I know it's on a bit more, it's on an advanced topic, but maybe could you say a small amount about impedance mismatching?
Oh, yes, this is a difficult topic. Most people, well, okay. So impedance is a quantity that you can measure about an electronic circuit. And it comes into play when you're transmitting radio signals. And your antenna has an impedance. The cable also has an impedance, and all the connectors have an impedance. And the connectors and the cables that are all compatible in this SMA standard have been very carefully designed so that their impedances are all the same. And so, and what we say is that their impedances match. So when you connect one cable to another cable, perhaps with some SMA adapters in between, what that means is that the radio signal will travel down the connector or down the cable, across the connectors into the other cable, and keep going just fine.
Smoothly.
Impedances match. If your antenna has a significantly different impedance, then the difficulty is that the signal will go down the cable and reach the connection to your antenna, and it will most of the signal will actually bounce back and reflect inside the cable instead of going into your antenna. And so you won't get very much radio signal coming out of your antenna and going to the laptop. This is a difficult phenomenon, and it's difficult to measure without some fairly expensive equipment, and it's difficult to impedance matching is a very complex topic. So the best I can tell you about this is experiment with several different antennas as you're building your antenna, and just see which one works the best.
Great, thank you.
I know that seems like a little bit of a lame answer, but I've actually talked to some real experts in this field. It just happens that that I work next to some people that do radio communications for a living. And I asked them to help me out with this. What can I tell students about how they can do impedance matching better? And they literally had no good answers except try building a few antennas and see which one works best.
Which is a lot of what Science Olympiad is about anyways, the trial and error and seeing what works, but just know that there's this thing out there that could be causing an error that maybe you don't understand why you're seeing. So, all right. I don't see any other questions. Ian, thank you very, very much for your time tonight. This was really valuable, and we look forward to seeing everyone at tournament.
Yes,